Okay, sorry about that. I start quickly. My name is Susan Mousavi, and I'm going to talk about a technological approach, how to address the cooling demand in Tehran, the capital of Iran. So the problem is we have energy deficit, and as per the formal reports we had in 2019, Iran government hit 21,000 megawatt energy deficit. At the same time, during the last few years, we experienced water and energy crisis, and we had significantly decrease in the amount of water in the reservoir and the rainfall. At the same time, we had the increase in energy demand by 5%. The damage, again, as per the formal report, only for the last year, for a few limited number of the days, electricity blackouts was about $2 billion. And if I want to address highlight the regulatory landscape internationally and nationally, at both scales, we have the Paris Climate Agreement. Iran is one of the countries who agreed to the climate change agreement, but it has not signed it yet. But among the 6 countries who has not yet signed the contract, Iran carbon emission is one of the highest, it's by 2%. And also we have the commitment for renewable energy production increasing by some number of percentage, but still we are very low in that scale. We have only 1% of energy production in renewable energy. In Iran, above 9%, average 92% of the energy comes from the fossil fuels in the power plants. So you can imagine that with very low efficiency, around 36%. So you can imagine that 2/3 of that energy from fossil fuels goes only for the air pollution, and there is no efficiency. And we have also one of the big crises in Tehran is air pollution, especially during the winter, fall and winter. As part of the compliance with the National Act, we had the policy in national level. As part of that, Tehran municipality, which is a big entity governing all the energy aspect of Tehran, has a 5-year plan how to decrease the pollution, air pollution, and how to increase the energy efficiency, and different approaches how to address these points. So, and they have done a lot of things, and a part of that is evaluating some of the sample buildings, how to address the energy efficiency and heating, cooling, and how to replace it by renewable energy, solar system, and so on and so forth. In all of these programs, strategic or I would say in a big picture, they address heating and cooling, not specifically on cooling demand. So what we do here, we want to know how to use different approach to decrease the cooling demand, not only energy efficiency, how to decrease it. One of the methods is using passive cooling or zero energy cooling. So passive cooling, simply, if I want to explain it, can be different types of production, but one of the simple one is how to use the cool paints and simply having on the roof, on the side walls, and so on and so forth, how to decrease the demand or cooling load on the spaces. So this similar study has been done in different regions around the globe. In Australia, they showed that having the cool roof will be very effective in lowering the cooling demand. And we had done a holistic and comprehensive study to see how the use of the cool paint can reduce the cooling demand for the municipality of Tehran. And if I want to explain it quickly, how the physics behind that is, let's say we have a surface and we have a radiation of the sun on the surface. So we have the heat gain, and also by radiation, and also the conductive property of the surface will tell us how much energy by heat we gain. So if we can reflect the part of the energy, at the same time, if we can emitted within the atmospheric window, so the energy gain will be down by significantly. So the surface itself remain cool. So the demand for the cooling will be very low. So there are different types of product. Some of them in laboratory scale, some of them are on the market. There are like cool fabrics, so they can be used for the humanitarian aid supplies. And these are like in laboratory. Some of them are in laboratory scale, some of them are in the market, but not really high efficiency as we expected on the theory. So this product, in the very simplest form and cheap product, can be in the form of a paint, like whitest paint. So this white paint can be applied to the surfaces. It has potential application in industry and household both. So that simply works in a way that if we have the surface, let's say a surface without the cool paint as compared with the surface with the cool paint. So as I said, the majority of the radiated sun will be reflected within the atmospheric window. So we can reduce the load by 87%. So we can imagine that if we apply that cool paint on the surface, how much the energy will be decreased as compared with the surface without having. So as a sample, we wanted to do the calculation if this approach works in cooling demand. One of the devices that's commonly used across the Iran, especially in Tehran, are evaporative coolers. They're working. There's a very simple one. Is like a box, and at the center we have a water pump, and at the around we have the wooden shield, I would say. So the water pump and go over this the woods, and then the air will be cooled and pushed inside the space. So what happened is during the hot days, so the irradiation of the surfaces will be really high, so the body will be hot and evaporation of the water will be increased by 3 times. So the nominal water consumption for evaporative coolers are 200 liters per day, but in the hot days, around like 100 to 112 days in spring and summer, so we will have up to 700 liters per day water consumption. So we showed how we can increase the efficiency of the evaporative coolers, and quickly with some set of preliminary data, we showed that if we have a sample building used by firefighters, this is under the evaluation by municipality of Tehran. So if we have the cool roof and the side of the building, as well as for evaporative coolers, we can decrease the amount of water consumption by 65%. We can reduce the amount of electricity bill by 87%. So in terms of the numbers in Tehran, in Iran, the energy, okay, that's a very small one, but I can explain you that the cost for energy and water is very, very cheap. It's the cheapest among the many countries. So in terms of numbers, it doesn't make sense for many entities by the government to implement that. But in terms of the demand, which we don't have enough to supply to the customers, that will help the municipality of Tehran. So in summary, we wanted to show how to have the cool paint be produced in middle average efficiency in Iran, how we can decrease the amount of water consumption by evaporative coolers. So evaporative coolers, we have 22 million devices across Iran, and every year we have like around 500,000 devices comes to the market. So you can imagine how much impact we can have on the energy efficiency. And yep, that's it.
Okay,
thank you for
your presentation. So any questions from the audience? No?
Yes, maybe one small question. I'm not certain, but I don't think like cooling is the only challenge, right? Because like during the winter, actually, it can get quite cold.
The cooling is?
not one of the only challenges because it can get quite cold in winter as well, as far as I know. But I'm not certain. Maybe you can say something about heating as well during
Yes,
winter
so
time.
those parameters have already been addressed by the municipality for heating, cooling, and mostly on focusing on insulation, how to insulate the buildings, blah blah blah. But for that, and people always have problem with that. Above when the temperature is above 35 degrees, which is like more than 130 days in the season, above 35, these are inefficient, meaning that people just turn it on, but it's not working. So the water consumption by evaporation and also electricity will hit the boundary. So yeah, so the cooling, if we address the cooling, we can address significant part of the energy deficit.
Okay. Any more questions? I have a small question myself.
Oh, sure.
So for this cool paint, what would be the effect of dust which can deposit, for example, on a flat roof?
On top of the paint?
Yes.
So the product will be is really the parameters, like visual parameter are really important in the effectiveness of the paint. So it has not been yet tested in the climate of Tehran, but we assume that we can control the dust and we can control other parameters with the shield and stuff that are already on the market.
I see. Okay.
Yeah.
Very good.
Okay. Thank you.
Thank you.
Thank you.
So thank you all for participating.